Hi, I'm Nikki, a full-time online A-level biology tutor at Tweedle's Biology Tuition.
Hi, I'm Michael, and I'm a full-time GCSE and A-level online maths tutor for Air Maths Tuition.
Today we're going to have a look at standard deviation and how it relates to both maths and biology.
Cool. All right, so I guess the best thing to do would be to define standard deviation. Okay, so what is standard deviation? What really is this thing? So standard deviation is simply the spread of data around the mean, okay? Otherwise known as the average distance. So if I give you a quick illustration. So if you think about the mean, the way we normally calculate the mean tells us that it's kind of like a centralish value, right? So if we say the mean is, if we represent the mean using this straight line and we draw loads of different data points around the mean, up, down, left, right, what you could do, right, is you could simply calculate the distance from each data point to the mean, okay? And all the standard deviation is literally just that average distance. Okay, so if you get all of these distances and take the average, that's what the standard deviation is, and that's how it tells us the kind of the spread around the mean.
Yeah, so in biology it's important students understand the difference between standard deviation and range. Standard deviation therefore takes into account all the data points, not just extremes like the range. How's it used in maths?
Okay, so for maths, particularly for A-level maths, you're going to need to know how to calculate the standard deviation of two main types of distributions. The first one is binomial distribution, and the second one is normal distribution. From a more practical sense, you can actually, well, you'll see that standard deviations used like in so many places, like for example, the financial world. So I used to be a trader, right? And what we used to do is we used to calculate what the standard deviation is, right? So say the standard deviation was about, you know, roughly around about here, this distance away from the mean. What we could do is we could, if the price of a stock or bond or a currency kind of fell out of that range, we would deem it as an outlier, and we would deem this to be sort of abnormal behavior. So if we saw that the mean was the expected value, then we would basically buy or sell a stock, so that kind of hoping that it would revert to the mean if it was an outlier. And we use standard deviations to determine whether it was an outlier or not. So it's a really cool way to make or potentially lose money at times.
Yeah. In biology, we use it to prove if there's a significant difference in data after a practical investigation. Is there a biological cause, or is it just due to chance? So you want to talk us through the formula?
Yeah, we'll do. Okay, so this formula, at first glance, it looks really, really convoluted, but it's actually quite easy once you start breaking it down. Okay, so here we have a square root sign. As we know, the square root sign, square root of 49 is 7, the square root of 81 is 9, etc. And then this thing we have here is called sigma. So it's a Greek symbol, which is used to represent the sum of different data. Okay, and we'll talk about those different data now. So here we have X, which is literally just all your different data points, which, Nikki, I'm sure you're going to go through later. And here we have what's called X bar or X hat. And this represents the mean of the data, okay? The mean of the data. So what we do is we take the difference, we square it, and we take the sum of all of those values, and then we divide by n, which just simply stands for the number of values, okay? -1. And that's pretty much the formula, how you use the formula. So should we go through an example now?
Absolutely.
Yeah.
So just bear with me a moment. So we're going to look at this example of height of 4 different trees in a forest, A, B, C, D. First of all, I would always start by writing out your equation, so you've got it there in front of you. And quite simply, we're going to calculate the mean height of the trees, so your X bar value. So everyone should know how to do that straight away. Add your 4 values together, A, B, C, D from the table, and divide it by 4 because there's 4 values, and our mean is 26. So from there, the next thing we've got to do is X minus the mean for each of them. So for tree A, which was 22, we're going to minus the mean, which was 26, and then square that value. So the difference is -4, square it, it's 16. And do the same for each of them. So tree B, it ends up being 1, tree C, 0, tree D, 9. And then because we've got the sum of all of those, we need to add the 16, the 0, the 1, and the 9 together, and that brings us to 26. Then we've got to deal with the underneath of the equation, so the n minus 1. So n minus 1, we had 4 trees, and 1, so that's going to be 3. So overall, it's 26 divided by 3, which gives us 8.66. And then finally, you've got to square root that 8.66, which, depending on how many significant figures you need to quote it to, in this case, 2.94 to 2 significant figures. In biology, it's really important at A-level that you quote it to the number of significant figures they are after. Okay? So
that's it.
That's it. It's quite a simple calculation when you know. So I hope everyone's found that useful, and Michael and I will see you next time. Thank you.
Bye.